My name is Everton de Matos, and I work as a researcher at TII. And in this talk, right now, I will talk about the seL4 and RISC-V, building a TE, building because it's a work in progress. So actually, just a bit of context for this project. It started, let's say, more or less 1 year ago. There was some effort from our side, from TII side, on this, but then it was just like one small group, or like, let's say, two persons working on that, and then it stopped, and recently, like 2-3 months ago, we start to work back on this track because we have now some clients engaging with TII in this topic, so this topic started to pop up again in TII. Then I started to work in this project pretty recently. But yeah, so my idea for this talk will be to show you a bit of context on the RISC-V TE, a bit of the related work, what we have in the area right now, and talk about our current solution, what we have been doing in TE, what we have right now working. So yeah, just a bit of context pretty quickly that the TE can help us solve, can be one of the solutions to help us achieve a better security in some of the scenarios, not like the optimal solution, but we can use TE in some use cases. And then in the scenario of the TE, the seL4 stands out as a nice tool that we can use as a secure operational system in the secure world of the TE. So just for context, this is pretty traditional TE concept image. For a background, this is one of the most accepted definitions of TE, in which basically we have a normal world in one side, and then the other side, the TE, or the secure world, in which you're gonna do your secure stuff on that side. And then, of course, we have communication between those two worlds, and some separation needed also for isolation between one and another. And what the TE can provide, some use cases that the TE can be useful for, is basically secure storage to store some sensitive data, some executive code in the TE side to avoid any problems with the normal world. It's pretty useful for crypto, actually. A lot of use cases that when you see a TE, some of the use cases, or maybe a lot of use cases, are targeting crypto in the TE side. Also, remote attestation and secure multi-party computation. So those are when you see a TE, those are the use cases that most appear for the application of a TE. Then we have like this idea of software TE and hardware TE. They are pretty complementary. Basically, you need some hardware guarantees or hardware enablement to be able to provide your TE at the end. And there are those two guys, pretty well-known guys, the ARM Trust Zone, that is this hardware extensions for ARM processors that also provide these two different worlds, the secure world and a normal world as a TE, pretty well-known. And on the x86, one example is the Intel SGX that also provide this hardware-based memory encryption, and the software services on top of it as a TE. So for RISC-V, actually, we don't have anything as mature as Trust Zone for ARM and SGX, for example, for x86. Of course, we have some ongoing discussions and specifications, but we are far from having, let's say, these on the hardware still. It is on progress on RISC-V, so that's why we believe it is a nice timing to work on the RISC-V TE and also targeting something similar in the future. So some related work that to mention that there are another groups, another people working with seL4 and TE. So we are not the only crazy ones working on that. There are more people, just to give some context. And basically, this one in the left is a pretty recent publication. It's from this year. Also, it's from the Technical University of Munich and also in collaboration with NEO. So the guys from NEO have some participation on this one as well. And basically, it is they're building a kind of ARM trust zone like TE for ARM. So they did this, and also in the other side here in the right side of the slide, we have this micro TE that was also an approach that uses seL4 in the micro TE, also targeting ARM. So we have those efforts on ARM, and if you search, we can see also there are some repos from University of Waterloo working with CamKeys to provide that TE. So there are some efforts. Of course, there are more efforts, but I just like highlight some of them just for context. On the RISC-V spectrum, there are also, of course, there are some efforts for the TE also. We have this first one from RISC-V multi-zone that is pretty much, let's say, traditional view of TE with the secure word, the normal word as well. And we have those other two approaches, this Penglai, and the Keystone that are like enclaves like TE that are also have been popping up in the last years. And specifically the Keystone one, they, on their presentations, is from University of Berkeley, if I'm not wrong. And during their presentations, they are also targeting to use seL4 both as a runtime or inside the TE and the S mode, and also in the machine mode as a security monitor. So they have those ideas, but when I was consulting last time their documentation, there is nothing official yet. So it's also a work in progress from their side to use the seL4 as a TE. Okay, so before I jump to our solution, I just want to present to you this view. This is actually the test group discussions, the APTE or the Application Processor TE test group specifications. This is under the RISC-V community. There have been has been a lot of discussions on this topic. There is the SIG for confidential computing in the RISC-V community. So this is a very a very important topic that have been discussing in the last months and also maybe for 1 or 2 years in the RISC-V community, and they come up with this architecture that should be something pretty similar in some ways with Trust Zone and SGX. So they have this idea, these APTE extensions to support these TVMs that are the TE virtual machines. That basically this is a class of hardware trusted execution environment, and this one will enable that either the OS and the VMM to maintain the role of resource manager, even with these modifications for the TVMs. And they introduced basically this TSM here in the right corner. That is, it will run in the HS mode, the TE security monitor, and it communicates with this TE interface, this TEI, and also that runs under this TSM driver. So this is what we're gonna have as by what we are understanding for the current situation of the specifications and TE on RISC-V. But the thing is that we don't have it yet on hardware. Probably we're going to have it in the future, but we don't have it right now. So for our solution, as we don't have the HS mode, for example, in the hardware, we are using the PolarFire. And then this is our architecture, that what we have now, what we have been working and testing right now. And basically the PolarFire, it has 4 application cores and 1 monitor core. And for our configuration, we are using the PMP for physical isolation in this case. And we have, right now we have the Linux, simple Linux in 3 cores, and the seL4 as a TE on the 4th core. And of course the monitor core for the HSS bootloader. So this is basically the structure that we have right now. And we have some CamKeys applications on top of it, on top of the seL4 OS. These CamKeys applications, they provide the TE services, and they use, of course, IPC to communicate between them. And I'm highlighting two of the applications here, the OPTE. The OPTE basically provides the TE services, so it can be pretty modular. We can provide different OPTE services. And for those ones, we are following the global platform TE specifications and some examples of services that we have providing right now. Crypto, secure NVM, PKCS 11, for example. So those are some TE services that we have been providing, security storage as well. The other CamKeys application on the right side is the system control. So basically, we use this CamKeys application to use the PolarFire system control services that you can see right here in this arrow. And it supports device ID read, SNVM read write, among others. Then we also have one CamKeys applications for the REE communication, that in this case is the rich execution environment as another concept. It's similar to the normal word, more or less the same, but in this case we call it a rich execution environment. So we have this RECOM to communicate between the seL4 side and the Linux side. We have been using a shared memory approach, and we have been following the RP message standard that it's available also in the PolarFire and in the Linux for the PolarFire. Before, we had actually implemented our own communication method. We named it seL4con, but then we decided to use the RP message that is like more standardized way for the PolarFire SoC. It has the already supported. And then at the end, we have created this seL4 tool that basically is a tool just to test our TE or to run the services of our TE. And basically it calls the services from the TEs just for testing. We can use random number generation, crypto, generate keys, write and read, puff test as well. We have been enabled. So this seL4 tool, it's our application, let's say, on the Linux side. So basically, this is the architecture that we have now, that we have been working. And for the next steps, the next step, like right in the corner, is to open source for this solution. By the means, what I have been doing the last week at least was just cleaning the code and stuff, putting it a more nice way to open it. And we have been doing some performance analysis, some performance evaluation, and these performance results will be in a paper that we have been working. The idea is to finish by this quarter, or maybe the longer by the end of the year. And more mid to long term, then we can say about next year, for example. Of course, we have been monitoring the specifications from the RISC-V community, because at the end, we want to follow that specifications and have this kind of TE services in our site. We have to enable also additional hardware features from the PolarFire. The transition to microkit, I think is pretty standard. And TII have been working our own RISC-V SoC with the virtualization extensions or the HS extensions. So by this means, we hope that we will be able to also implement the AP TE stuff from RISC-V community, and also be able to provide our, let's say, complete TE solution more standardized. So yeah, I hope you I gave a nice understanding for our work to you, and thank you.
Thank you, Everton. That was awesome. Question, Gernot.
I didn't see seL4 in monitor mode. Why not?
No, yeah, actually, we started in the supervisor mode. We are using it by now, but we have been exploring these kind of solutions. By now, what we tested, what is working from our side is in the supervisor mode, but we plan to test some
But a bit more serious. If you have seL4 in monitor mode, why would you need any hardware support at all, like any hardware enclave?
Yeah, yeah. nice. We can target this for sure.
All right, we have some extra time, so any other questions? All right, I have a question. How much effort was it to implement the OPTE stuff and so on? Was it ported or did you do it from scratch?
No, it was ported. Yeah. So we used it. There was some efforts already in the community porting OPTE to RISC-V. So we gathered this and did just some adjustments to work with seL4, for example.
Okay.
And on the seL4 side, on the kernel, we added basically the DTS for the PolarFire AMP configuration and some system call for the inter-hard communication with the HSS. So.
Cool. All right. Anyone else? No? All right. Thank you.